Know that when a plane intersects a cone at any place other than the vertex, such that the angle beta between the plane and the axis of the cone is less than the angle alpha between the axis and the generator of the cone, and more than or equal to 0 degrees, and the plane intersects both the napes of the cone, the resulting conic section is a hyperbola. Notice that a hyperbola is made of two curves that appear like mirror images of each other. Consider two fixed points F1 and F2 in a plane. Now, consider points P1, P2 and P3, such that the difference of their distances from F1 and F2 is equal. Then, the curves passing through all such points form a hyperbola. Thus, a hyperbola is the set of all the points in a plane, the difference of whose distances from two fixed points in the plane is constant. Remember that to find the difference between the distances of a point from the fixed points F1 and F2, we always subtract the distance of the nearer fixed point from the distance of the farther fixed point. The fixed points in the plane are the two foci of a hyperbola. They are jointly called the foci of the hyperbola. The line passing through the foci is called the transverse axis of the hyperbola. The 2 points where the transverse axis intersects the curves of a hyperbola are called the vertices of the hyperbola. The midpoint of the line segment joining the foci is called the center of the hyperbola. The line passing through the center and perpendicular to the transverse axis is called the conjugate axis of the hyperbola. The distance between the two vertices of a hyperbola is considered the length of its transverse axis. Thus, if A and B are the two vertices and distance AB is 2a, then the distance of either of the vertices from the center of the hyperbola is a. The center bisects the transverse axis into two semi-transverse axes. Also, if the distance between the two foci is 2c, the distance of either foci from the center of the hyperbola is c. Now, here is something just for your understanding. The intersecting blue lines that you see passing through the center of the hyperbola are called its asymptotes. An asymptote is a tangent to the hyperbola at infinity. If you draw a tangent to the hyperbola through any of its vertices, the tangent intersects the symptotes as shown. Draw perpendiculars on the conjugate axis from the points where the tangent intersects the asymptotes. The distance between the 2 points where these perpendiculars meet the conjugate axis is considered the length of the conjugate axis of the hyperbola. You just have to remember that the length of the conjugate axis of a hyperbola is represented by 2b and gets bisected by the center. The center bisects the conjugate axis into two semi-conjugate axes. Now, we can state an important relationship between lengths A, B and C. If the lengths of the semi-transverse and semi-conjugate axes of a hyperbola are equal to A and B respectively, and the distance between its foci is 2c, then b squared is equal to c square minus a square. Now, let us find the difference of the distances of a point on a hyperbola from its foci. Let P1, P2 and P3 be any 3 points on the hyperbola. By definition, we know that the difference between the distances of a point on a hyperbola from its foci is constant. Let this constant be k. Consider vertex A that lies on the hyperbola. The difference in the distance of point A from the two foci is given by AF2 minus AF1. Since AF2 is equal to AB plus BF2, we get K is equal to AB plus BF2 minus AF1. Let this be equation 1. Now, consider the other vertex B that lies on the hyperbola. The difference in the distance of point B from the two foci is given by BF1 minus BF2. Since BF1 is equal to AB plus AF1, we get K is equal to AB plus AF1 minus BF2. Let this be equation 2. Equating the values of K from equations 1 and 2 and simplifying, we get BF2 is equal to AF1. Substituting the value of AB as 2A and BF2 as AF1 in equation 1, we get the value of K as 2A. Similarly, from equation 2, we get the value of K as 2A. This is true for all the points on a hyperbola. The difference between the distances of any point on a hyperbola from its foci is equal to the length of the transverse axis of the hyperbola.